Uh, we can mute ourselves. Yeah. So hello, I am Dennis Pauly, and I'll be introducing Team 37's language. We called it LaxScript. It was just a play on words from relaxation scripting. So let me introduce what I had done. So I had actually set up the Antler uh, files and basically denoted our grammar into this laxscript.g4 file, as you see. So we had gone through like declarations, initializations, printing statements, then assigning identifiers for integers, strings, and booleans as well. And if you go down a bit more, Keshav, uh, keep going. Yeah, so we had also introduced multiple operators like the unary operator, ternary operator, and we just created conditional situations and assignment operators as well, because we'd want to assign variables to certain values. And we also additionally, from our previous grammar, we had implemented syntactic sugars. So essentially to make the expression smaller than it is. And moving on, we had gone to conditional statements and loops. So we talked about if condition and while condition. Keshav, we can go down a bit more. Yeah, so keep going. So then we talked about, we also implemented the for loop and for range loop. So you can see the formats are there. And then we just talked about the expressions. So these are basically the arithmetic expressions in our language. So we covered addition, subtraction, multiplication, and division. And then this is how we denote our sentences, identifiers, special characters, and numbers. We've set those requirements here. So sentences are just anything, like anything with between two double quotes. Identifiers are just either it could be single alphabets and or it could be multiple alphabets as a single identifier. And we've also just checked for special characters in case any special characters appear in our program. And finally, we created just a check for like, if you're doing a new line, our program would essentially detect that new line in the script. So Keshav, if you go down a bit more. Yeah, so we do detect the tab spaces and new lines as well. And the \r is for like new lines in Mac. So we had to implement that as well, because we are running our systems on Ubuntu as well as a Mac. So just in case. And essentially after this, we just have to create we just have to generate the file. So Keshav, if you could open the parser folder. Think that's where the, yeah. So if you right click on the laxscript.g4 file, uh, yeah, you could essentially just generate an antler recognizer. If you see that at the bottom, right now we don't want to do that, but okay, never mind. We actually did that. But essentially you'll get a gen folder, which will contain all the generated files. So Keshav, could you open that for me? No, just open the gen folder for me. No, top left, gen. Yeah, there we go. So essentially, these are all the classes that are generated from our lax script. And then we just implemented an evaluate function, which Sneha and Saurabh did. So I'll pass it on to them. You can delete the gen file, by the way, Keshav. Yeah, please delete that. Thank you. Okay, so
Yeah. Hi, I am Sneha, and I and Saurabh worked on the Lex script evaluate function. So Keshav can, yeah. Okay, so I work. So we have used hash map to store the data. Like whenever we have to update any variable, then we need to. There we have used string, integer, and boolean, three data types, and I've worked on the initialization functions for the integer boolean, and like, can you scroll over, Keshav? So there are other functions like post increment and pre-increment functions, and basic arithmetic functions for addition, multiplication. So that is what I worked on. So Saurabh will continue further.
Yeah, so my name is Saurabh. So can you scroll down, Keshav? So take me on line number 347 to be precise. Yeah. So the functions that I've worked on is the arithmetic function, you can see. So can you scroll more down? 390 around here. So here we have addition here. So we have your arithmetic functions like addition function, then we have subtraction, then we have multiplication. Can you scroll down? And then we have division. So for implementing this function, we have used the hash map implementation where we store the values, that is a value 1 and value 2. And depending on the values, we perform the functions, that is addition, subtraction, division, etc. And then can you scroll more down? So we have other functions too. Yeah. We have the multiplication equals to ID. Yeah. Can you scroll more down? We have division equals ID. We have visit, then if, then condition. Yeah. So these are all the functions that were implemented by me. Yeah, that's it from my side. So now we have Vashishtha.
Yeah, we'll move on to Vashishtha. Vashishtha, you can explain your implementation.
So this is basically main class. I worked on that. I implemented the main class, which it will first check that the file extension is like valid or not. It is like .lex or not. Then once it is validated, we will then read the file and store the data in a character string. And after that, we create a parse tree for it and then run it against our evaluator function. Yeah, that is basically what main function does.
So I'll continue. My name is Keshav, and I worked on integrating everything together. I also worked on writing the test cases according to our grammar, and I'll just demonstrate what the test cases programming language can compute. So I'll go to the data folder, and here, as we can see in the README. So we have generated some test cases covering all the functionalities that our programming language demonstrates. I'll start with the basic operations, which is the basic arithmetic. So here, as we can see, this is computing the basic arithmetic operations like addition, subtraction, multiplication, division. And we've also checked the syntactic sugar, B++, B-, and so on in this file. The next case that we covered is the basic if. I'll just run this. So this checks for if a number is single digit or not. And it's a basic if loop that this test case checks. Next, I'm going to demonstrate the for loop. We've implemented a basic factorial function through the for loop. And so this function is computing 5 factorial. Next, I'm going to demonstrate for range loop. Similar implementation of factorial, but through for range loop now. For range loop is working fine. Then we have checked for the ternary operator. So here we have two numbers and the program is computing the condition through the ternary operation specified here. Finally, I'm going to demonstrate that our programming language supports while. Again, we've implemented the factorial, 5 factorial to be precise. And it computes 5 factorial just fine. So we have 3 loops, the conditions, ternary operator, and if, and yeah, our programming language seems to be working just fine for these operations. I'll ask Dennis to take over.
Yeah, so as you can see, the rest of so we actually had to create a jar file. Essentially, we just compress all our files into this jar and we run it against that. We were thinking of going for a shell script optimization to just keep the task simple, but we did face certain issues with it. But nonetheless, this approach still worked for us, so we are planning on sticking with just running the jar file directly. And we also had to get the Antler 4.10.1, since this was a version of the plugin that we needed for generating the Antler files. So yeah, I think we've kind of covered a lot of the functionality as well as the grammar, and I appreciate you guys for listening and being here. Yeah, so thank you.
Thank you.
You can stop the recording.